We are looking at a simulation of high-speed data flow across a network. Every time a user types into a login screen, a checkout page, or a sign-up form, an application has to capture that text and verify it. Email validation is a universal requirement to keep this data flowing securely. Python handles this kind of human input using the string data type. A string is a collection of characters used to store and manipulate text. We are going to build a functional email validator script from scratch in under 6 minutes to filter out bad data. To follow along, you only need a standard code editor and a basic understanding of Python variables. By mastering string manipulation, you control the mechanism that turns unpredictable user text into clean, structured data. Step 1 is capturing the user's data. We need to tell Python to pause its execution and wait for character input. Here in the editor, we set a variable named email and assign it to the input function, passing the prompt, enter email. When we run this code, down in the attached terminal window, a live prompt appears, blinking and waiting for a response. Whatever you type into this prompt, whether it's letters, numbers, or symbols, Python stores it as a string. It treats the entire entry as a sequence of characters bound by quotes. Isolating this input correctly is our starting point. All the security checks we write next rely entirely on analyzing this exact sequence of characters. Now we establish the rules. A valid email address requires 3 structural elements. It needs an @ symbol, it needs a period, and it cannot contain any spaces. Looking back at our code, we translate those rules into this conditional logic block using an if statement. Notice the keywords highlighted here, in and not in. Python uses these operators to scan our main string and check if specific characters exist inside it. If the condition is met, we use a print command to output valid email. If not, an else statement triggers a print command for invalid email. If a user enters admin@gmail.com, the script detects the @ symbol and the period, finds no spaces, and passes the check. But if they enter admin@gmail.com, the missing @ symbol and the illegal space cause the check to fail, triggering the rejection state. This basic conditional check acts as our first line of defense. It discards obvious formatting violations right away, saving system resources for deeper processing. We can increase the script's precision by moving past basic structure and verifying a specific domain, like checking if the user submitted a Gmail address. To do this, we add a nested if statement, utilizing a built-in string method called endsWith. This checks the final characters of our string against the exact text @gmail.com. You have to be careful when applying methods like this. If a developer accidentally tries to use a string method on numerical data, Python will throw an attribute error and stop the script. If you try to manually correct a typo by changing a single character, like trying to swap the first letter using an index, Python triggers a type error. This is because strings are immutable. Once they are created, individual characters cannot be swapped or corrected in place. Immutability dictates how we handle data. Because we cannot overwrite mistakes directly, our application must reject the flawed string entirely and request a new one. Combining built-in methods with an understanding of immutability ensures we verify domains accurately and prevents crashes caused by illegal data manipulation. Right now, our script relies on static text. To provide clear feedback to a user, we can generate dynamic responses that include the specific email address they entered. We achieve this using f-strings. They are the modern way to inject variables directly into a line of text. In the code editor, we transform our basic print statement into an f-string by placing the letter F right before the opening quote. These curly braces map the external email variable directly into the sentence structure, exactly where we want the user's input to appear. F-string formatting clarifies the connection between our logic and the feedback the user sees, making the script's output much easier to understand. With the code complete, we run a rapid-fire testing sequence to prove the script responds reliably across different inputs. Test 1 inputs a flawless Gmail address. The terminal outputs our dynamic success message. Test 2 uses a valid non-Gmail address. The branching logic outputs the secondary confirmation. Test 3 inputs an address with an improper space. The rejection logic triggers the invalid format message. The validation sequence is completely operational. We have successfully built a tool that effectively filters text data. The string evaluation logic we used here is the starting point for any tool that handles text-based data, including the search engines and data pipelines that power modern software.